I'm sending from the left-hand side towards the right-hand side to reach the destination. So first thing, what do I have? I have what's my IP source? Okay, 45 is it?
Yeah, 45.
Ending by
0, 29.
So 45 to 23. Sending it towards an IP destination starts with 129.
Yeah.
Ends with
24.
24? 28. Why do you see 3? So that's your IP source and IP destination. So what's your MAC source? So it starts with 45,
That will be
ends up with your MAC destination now. What is it?
46.
46 ended with 29.
29.
So at the moment, you just deliver the packets from the source to as the router number 2, the first interface. That's it. The first part of the question. So that's number 1. Second part, I keep my IP address and my source and destination the same. I change only my MAC addresses. So what's the MAC source now? So I'm passing on the router, the same router, from the router number 2, interface number 1, to router number 2, the same router, but interface number 2. You can't say that, you can't mention the details, that's fine with me. So it's just if you want to say passing on the information from interface number 1, let's call it interface 1 and router 2 towards interface 2 and router 2. Okay, so that's the second step. What's the third step now? So now the actual packet is starting at interface 2, router number 2. How can I pass it to as a destination? What do I do next? You can constrain. Okay, IP source stays the same. IP destination, same as well. MAC source, MAC destination. What are these? So MAC source at the moment.
It's going to be D3.
D3, exactly.
78.
78.
Yeah. So
Destination.
D4.
D4.
And 3E.
3. So I'm passing on the packet now. From here to.
You skipped one step.
Did I? No, I just skip it.
Which one?
I just said that this arrived here. I'm passing on from interface number 1 to interface number 2. You can't mention full details, or you just say I skip it here. Because they are the same router eventually. You can't mention the details, that's fine. If you want to say I'm passing on to different interfaces, that's fine as well. For simplicity. You know what I did? You can't say the full details here. So if you want, you can give me the MAC source, which will be 4629 passing on to as D378.
So it's the same on the
It's the same, yeah, so it's fine with it. Okay? Fourth step, what is it now? We are now residing in this stage. Now we will pass on the packet from the interface number 1, from the router number 1 to its interface number 2, router number 2, which is D43E with D479. That's the source and destination. Shall I write it down?
Yeah.
IP source
Still the same.
and IP destination stays the same. Meanwhile, the MAC source at the moment is well be as D43E.
Or router 2.
What do you want to do? You want to do the first one?
Yeah, E1. Yeah.
I'm here.
Yeah.
So it's
E1.
D4, E3.
Interface 1 to router.
That's fine. That's fine.
router
Yes, I'm
1.
going to give the full details. They want the
Oh.
full details. So that's D4 ending with 3E passed on to D4 7. Final part. So now I'm residing at this stage. What's the MAC source and MAC destination?
D4.
So that's D4 79
36.
36.
8B.
That's it. Any questions?
Is this 61?
No, there's another part missing.
Oh,
16. 16, that's too much. So, yes. So, what's missing? So now I'm assuming every router has its own ARP table. So ARP table are defined properly in each one of those routers. What are ARP tables? Associating MAC addresses to IP addresses. Okay? I skipped an actual slide to show exactly how do I react if there is a missing IP address associated to a MAC address. So if I say the same question that we had here, so let's say that if I reach router number 1, and I say that router number 1, there is no ARP available, i.e. there is no association between the interface number 1 and router that router. So I don't know the information of that MAC address, whether that's the right IP address. How do I create an ARP table that will be based on that request? So what do I need to know? If I reach a stage where I try to make sure that each device maintains an ARP table cache, mapping an active IP address towards an address to a MAC address. So what exactly do I need to do? I create what we call a request type for the IRP table. The structure of the actual request will look like this. The structure is I'm trying to send, so I'll reach the stage where I'm trying to send from A, and that A was, for example, router number 2 with interface number 2, towards the destination, which is B, with its own interface. So I don't have an ARP table. So what do? I need to send an information, a request, to say, where is this IP address belongs to which MAC address? Because you have the source and destination. In the beginning of the question, I say, your IP address of source and IP address of destination, which are fixed. I've already said they are 111 ending with 11 towards 222 ending 222. We say that and we didn't change that. We changed the MAC addresses. So how do I now create that ARP table? That ARP table is missing. So there is a request. We call it an ARP request type. The structure of the actual request will look like this. It has two types of structuring, and therefore you'll have MAC source, MAC destination, the type of the request, which is request type, and here you try to associate the fourth parts, which is MAC source to the IP source, MAC destination towards the IP destination. Let's fill the gaps. What's the MAC source? We have the MAC source because we reached the place in R2 which we know the MAC source of that destination. So A is trying to know the MAC address of the destination. So how is that being done? MAC source is just A's MAC address. So that's MAC address of A. Because A is trying to send. He knows his own MAC address. He's trying to send to a destination he doesn't know the MAC address to. So that will be a broadcasting request. FF ending up with FF. You are broadcasting it inside that subnet. That MAC source, now you have the MAC source, which is MAC source of A. IP source, you have that. It's not being changed. Start with 111, ends with 111 as well. MAC destination, you don't have that. Question mark. And then you have an IP address of destination, which is, we have it as 222, ending up with 222. So what's missing is you're only trying to broadcast that information, and you're asking whoever is the IP destination, which is 222, just bring me back your MAC address. So if I'm B, which I'm 22 ending with the 222, I will reply by saying, yes, it's me. I'm trying to reply with a reply message, a reply request, filling out the same information. So what will be the details of the reply? Now you reply with your MAC source. You know your MAC source. You say your MAC source are MAC B. You've received that message which has MAC A destination, i.e. the MAC address, you say the destination now is MAC D, which is not D, sorry, A. Reply type. IP address stays the same, MAC address changes. So IP address of the source, at the moment, what is it? So this one is replying to
the B.
So that would be to exactly 222 and you 222. You know your MAC source at the moment, you already sent it, so you know your MAC source, so that will be MAC of B. What's the IP destination at the moment?
111.
No.
No.
The router.
Be careful.
The router.
What's the MAC destination? I said IP destination, which is, what is it exactly? Who was sending? If I go back to the to the actual example, I start at router number 1, and router number 1 is trying to fill out the details. So what's the IP here source? Is it the same old source? Who's requesting? Is it A? Is it this device requesting at the moment? Or is it that device, that side is requesting? So R1 is requesting. So in other words, your IP source at the moment is 129.2.1. That's where you change your IP address. That's the only place you change your IP address. Because now router number 1 is requesting information, not actually the full destination of router number B, which is this one. That's the only change. So whenever that replies to the destination, so it should be now here, the source should be of A's IP address. And in here you have the IP address of destination A, which is, in that case, 129.21, and the MAC destination of MAC A. What did you do at the moment? You created the RP table for who? For router number 1. You haven't delivered the packet, by the way. This is just a request type. That's the only type we call it a request at the moment. The actual packet is still residing on router number 1. It's not being sent. You're just trying to fill out the gaps of the ARP table, the missing information. So you created the entry at the moment, and afterwards you start sending now the full packet to us at the destination. You continue with your question by the full details. Is that clear? That part. I repeat that. That's fine. I'll do that again.
I get that ending bit, but I don't get the first two.
Okay, I'll do that on this example. Okay, in full details. So let's go back to your paper. You already done the example already. So you have the examples on the paper itself. What do you have when you reach router number 1? You reach router number 1, you have the information here. You said I've reached that stage and I'm trying to pass out the information from MAC this one to MAC this address. Is that right? Yeah. You are residing here. So let's start from this place. If I start from here, is that clear?
Yeah.
So in here I have an ARP table that's empty, that's not available. So I don't know the MAC address, I don't know the IP address of the destination belongs to this MAC address. I want to request the ARP table. That's what I'm doing at the moment. I'm creating an ARP entry for the router 1. That's it. How do you do that? With that structure of the actual frame. What changes, just now assume that you are starting from that place. That's it. So I'm residing where? In interface number 2 and router number 1. Tell me that now if I try to send, let's do it that way. If I'm trying to send a packet, usually I'll say IP source, IP destination, MAC source, and MAC destination. I have the IP source, which we said that in this example was 4523. The IP destination is 129, ends with 23. Is that right?
Yeah.
So I'm trying to send a packet at the moment. MAC source, if I'm here, what's your MAC source? So it's D4,
Yeah.
ends with
39.
39.
No,
79.
No, because the MAC address is MAC.
Here's it, you're sitting here.
Yeah, but
If you pass it on, I said if you reach that stage, you're sitting here.
Then
Which one is missing then?
This one is missing.
Oh.
You're creating an RP table to your destination. But this is missing. Okay? So what do you do? So if I say that's MAC source, what's your MAC destination at the moment? Which is missing. What do you write? You don't have anything. You cannot send it. So what I'm doing is I'm filling this missing information. That's broadcast I'm going to do in a minute is just filling out the MAC address of the destination. Okay? So if that was available, you should just mention 36.3. That's it. But again, that's missing. So what I do, you fill out the information by a request type of information, which is a structure which looks like exactly like this. You have MAC source, MAC destination, request type. Why I'm mentioning this request type? Just to distinguish between forwarding the packet and requesting the information. That's what I'm trying to do, just to distinguish between those two. Then I have association between MAC source, IP source, and MAC destination, IP destination. Tell me the information. Let's fill the information here. What's your MAC source? I'm sitting on interface number 2 on router number 1. MAC source. So D479. MAC destination. It's not available. So what do? You say broadcast. Start with the FF, ends with the FF. That's a broadcast. Request type. What's your MAC source, which is we just mentioned it, D479. What's your IP source at the moment? Where am I residing?
Is 129
21.
21.
Exactly. Who's sending the message? Is it this router or is it that machine?
That stage is that one.
That stage is this machine, which we need to be the fill the information of that machine. That machine is actually requesting the information to fill out the RP table. That's why I've changed it now. So that's now 129 ends with 21. MAC destination, we don't know it.